Good day, everyone. So, our discussion for today focus on Cartesian vectors. We will also determine how can we represent Cartesian vectors, find the magnitude of a Cartesian vectors, what are the directional angles, and how can we find the unit vectors of a Cartesian vector. Okay, so that is our goal for today. So, at the end of this class, hopefully, we can answer this problem in which express the force shown as a Cartesian vector with this figure. Okay? And we will also find what is the unit vector and directional angle since the magnitude is already given. So, what is the difference of Cartesian notation to a scalar notation? So, if you will look here, you can see two pictures. Okay? So, my force is lying on xy plane, both of them in xy plane. Here, I will draw here the scalar notation, and for this one, I will draw for the Cartesian notation. So, what is the difference between the two? The main difference of these two is, for scalar notation, we represent our direction by positive or negative sign, in which, since this is my force, so I can assume in positive x, this is positive, okay? And for the direction of the component of the force along positive x, well, for y, okay, that is also positive because the component of my vector is also positive. So again, so here, my fx is positive because it's lying along x, so I will just put positive, while for here, the component of my force along y is also positive because it's lying along positive y, so I will just indicate it. While for Cartesian notation, okay, we are not using positive and negative for direction, but we will use for this, so x is our I hat and y is our j hat. So, if we will indicate our force here, so this one, we will just get the magnitude of this, so that is fx, whatever the component of this, the component of our force along x, so this is the force vector, and this one is, what is the magnitude of this along y, so that is our fy. Now, to indicate that, okay, so, our force x, the component of fx, which is a force, is equal to whatever the magnitude of that times I hat. While for fy, what the component of fy along y direction is whatever the magnitude of fy times j hat. While for, if we will go back for the Cartesian, we know the direction is just positive and negative. So, how can we determine its magnitude? For scalar notation, it is needed that we find the angle. Okay? Unlike in Cartesian vector, okay, in Cartesian notation, angle is really not needed to find the direction or to find the value of our force. So here, we can have fx. So this is the direction. So if we will make this as our force along x, so that is positive, whatever the value of the magnitude of f, cosine theta. And that is how to solve the x component of our vector f. For the y component of our vector f, that will be, so that is positive again because this is lying along positive y, so it is whatever the magnitude of f, sine theta. So, to finally determine our force vector, so for scalar product, it will be just like this. So, for the force vector, it's represented by fx or fy. While for Cartesian notation, we can have our force as fx I hat plus fy j hat. This one, we cannot form this into an equation just like this, okay? Because if we will do that, it might be, there is a tendency that you might add them because there is no indicated direction. So we will just stay our components just like this. Okay, so I hope that is clear in discussing what is the difference of a scalar notation to a Cartesian notation. We will now deal more on Cartesian vector. Let's have this one. So usually we draw our axis just like this. So this is, for example, y, and this is x, and this is z. So since in some books this is not the orientation of our axis, we have to rotate this one. So I have to rotate this clockwise. So my y will be getting here, and my axis will be in front. So here, and my z-axis will be in this position. So how does it look? So it will be just like this. So again, this is my z-axis, this will be my y-axis, and this will be my x-axis. So please remember this orientation because our next topic will be in this orientation. Let's assume we have a vector A. So let's assume I have a vector A here, and it is lying along a positive. So this is positive x, positive y, and positive z-axis. Okay, so our vector is in a positive octant. We are dealing for octants, 8 octants. So we are in the octant of positive x, positive y, and positive z. So we can indicate its components on x-axis, y-axis, and z-axis by drawing this so that I can easily identify. So this is my vector, and I have to draw the x component of my vector A on this axis. Means the length of its component of x is in this direction. So that is ax. And I will indicate later, so based on the Cartesian vector, this will be the magnitude, and I will indicate I hat for its direction. While for my y, so based on this is my ay. This is the length of my component of ay in y direction. So this will be j hat. And for my z, this is the component of my vector along z-axis. So we will call this as az, and the direction is k hat. So that is how to write our vector. So it means my vector A can be written as ax I hat plus ay j hat plus az k hat as Cartesian vector. Okay, in Cartesian notation. For example, the given vector is in this form and we want to get the magnitude of that. So to indicate the magnitude of our vector, so we will just have A is equal to the square root of ax squared plus ay squared plus az squared. That is how to get the magnitude of the vector. So other than magnitude, we can also find out the unit vector of this vector A. And we have to remember our A vector is pointing to a direction which is the same with our unit vector. Since my unit vector is in the same direction with my vector A, so they are in the same direction. And from this form, I can generalize that this can be written as A, whatever the magnitude times the unit vector of my vector A. Okay, so it means A can either be written as this, so as Cartesian vector, or A can also be written as what is the magnitude of A times the unit vector to represent it as A. Okay, so this is the general form for unit vector. So in short, A is just equal to the magnitude of A times its unit vector. So hence, we can solve for the unit vector as Cartesian vector, okay, so that is A, divided by its magnitude. So it means if I will place all the values of A, Cartesian vector A, so that is A, x over A divided by the magnitude I hat plus AY divided by the magnitude of A, J hat plus AZ divided by the magnitude K hat. And this is the formula for unit vector. So, other than the magnitude, other than the unit vector, we are also going to find what is the direction of the vector reference to its positive axis. We call this as direction angles. Direction angles, so please remember, so this is the angle of our vector coming from its positive axis. If we have here a vector A, so I have here the vector A, this one, the angle between vector A going to my x-axis is what we call alpha. And the angle between my A vector to y-axis is what we call beta. And the angle between z-axis to my vector is gamma. These are what we call direction angles. So the easiest is gamma to imagine. So if we will look here, okay, so this one is, so this is z-axis. So this is z, and this will be my vector A, and this is my gamma. So this one, the component of A along Z is AZ. And since this is gamma, we can have the relationship using cosine. So, based on cosine, cosine gamma is equal to, so that is AZ over the magnitude of A. Okay, so this is the formula for direction angle. And for alpha and beta, it will be also like this. So this one, if we will picture this out, so this is beta, and this will be the right triangle of AY. It will also be 90 degrees reference to beta. So if we will look this in 3D, that is also 90 degrees. So therefore, I can write here cosine beta is equal to AY over A. And the same with alpha. If we will look this in 3D form, we can have this one as the right triangle reference to A. So, cosine alpha is equal to AX over A. So, these are the formula for the direction angle of our vector A. And if we will go back our formula for unit vector, we can see that AX over A is also cosine alpha. AY over A is also cosine beta. And AZ over A is cosine gamma. So, I can have my second formula for my unit vector as cosine alpha I hat plus cosine beta j hat plus cosine gamma k hat. And this is the second formula for the unit vector of u. I have to note that there is an identity dealing unit vector. This will be useful in solving in math. Cosine squared alpha plus cosine squared beta plus cosine squared gamma is equal to 1. Again, this is a math identity that will be useful throughout our solving problems related to unit vectors.